Welcome to solverfy.
This is a very interesting question. Think of it like this. You have a piece of ice floating in the water. Let's say a portion of it is submerged. Now, if the portion of the submerged portion has a volume V, it means that the buoyant force will be V times the density of water times G. Now, this will be equal to the buoyant force, which is equal to the weight of the ice block. Now, once this ice turns into water, it will still have the same weight, but now its density will be equal to that of water. So its weight will be mass times g. Now you can cancel g, and mass is equal to v times rho. Now this v is this volume, and if you notice, rho is also the density of water, which means this mass of water will have this volume v, which means once the ice becomes water, it perfectly fits into this volume, which means the water level stays exactly the same. It's almost magical. But what happens if there is an air bubble? You can think of it in a slightly mathematical way. If you have an air bubble in an ice cube, its total density, its average density will be less than the density of ice. But an easier way to think about it is like this. You have a piece of ice which has an air bubble in it, and obviously there is water here. And now once the ice melts, the amount of water displaced will be the volume of the water displaced will equal the weight of the ice. So the water in the ice fits exactly in this volume. So it must still be the same. But the answer will be different if you have a grain of sand, though. If you have a grain of sand, let's say somewhere over here, the total density of the ice cube will be larger, the average density, and once the ice melts, the sand simply falls down, which means this this piece of ice was further lower in the water than it would have been if it was simply made of ice. So to make up for that, when the ice melts, the the volume of the water will be less than the amount of water displaced. So the level of water will decrease if there were a grain of sand in the ice. So you would expect that the water level would rise if in the case of the air bubble, but the density of air is so small that it simply doesn't count.